Hello and welcome to Hydrovar X training. I'm Josh Kingsley from the Xylem Industrial Marketing Team and your facilitator for this program. We are live from the Little Red Schoolhouse at our Morton Grove facility. Key reminder, this is interactive, so please ask questions via the Open Teams chat, but continue to watch the broadcast here for the best experience. I, along with Sarah Bonham, who is part of the industrial marketing team, will be making sure all questions are asked and answered on the stream. And with that, I turn things over to Derrick to kick us off.
Good morning, everyone. Thanks for joining us today. My name is Derrick Oberdorf. I'm the Americas Product Line Manager for our Monitoring Controls portfolio. I'll be covering the Hydrovar X material today. Just to reiterate what Josh said, feel free to throw questions into the chat whenever you have them. He'll interrupt me so I can take a minute to get those answered for you as we go through the presentation slides here. So jumping right in, this is some of the training outcomes, a bit of a high-level agenda of what we're going to be going through. Just want to help you guys understand some of the industry trends and problems that we're seeing customers have and which Hydrovar solves. Understanding which products will use Hydrovar X moving forward, awareness on how the technology works and how to interact with it, whether that's installing it, commissioning the product, and really that's it. So we'll start to go through that stuff now, kicking off with the macro market trends that we have seen in the market, talking to customers, distributors such as you. First, these are the four high-level ones, being integration. Everyone wants, take advantage of lower installation and commissioning costs. With integrated design, you're getting everything together, the pump, motor, VFD. We are already doing the wiring for you at the factory, programming it, just saving a lot of time and money out in the field. You're not having to purchase and run long cable leads between a VFD and motor out in the field. You're getting a smaller footprint now with this type of products. And then simplified supply chain. You can go to one spot, get everything you're looking for, and now you're not purchasing multiple part numbers for a pump, motor, VFD. You are ordering just a single part number now and getting everything you need. The next one is efficiency. This is a big one on the global scale, especially in Europe, where there's some new regulations in the pipeline that will require higher efficiency standards and basically the use of VFDs to achieve those efficiency levels. However, we are typically here in the United States, a few years behind, and we typically end up getting similar regulations in place. So it just gets us ahead of the curve. Aside from that, though, having more efficient product, you can take advantage of even lowering your life cycle costs more and take advantage of some energy rebates that are offered out there. Next, we have intelligence. So historically, a lot of our customers love the benefits and features a variable frequency drive would offer them. However, they get a bit overwhelmed once they're interacting with it. There could be hundreds or even thousands of parameters and settings within a VFD that get people kind of overwhelmed, as I said. So they want that intelligence, but with a bit of an easy button. And not only from the startup or commissioning standpoint, but also with the health of that asset. They want to know what is going on with it, if there is a problem, what is the problem, and how do I take care of the problem to get this back up and running. And then lastly, connectivity. This has been a big one, gaining more and more popularity, especially the past couple of years, is connectivity. Just being able to pull up your smartphone, open up a laptop, go to a web page, a smart platform or mobile application, and check in to see how your system is operating at that time, just to give you peace of mind remotely. On this slide, I just like to focus on the blue box there in the center of the screen, some of the everyday challenges and pain points. First, is poor situational awareness. Even if you are an expert in the field in the pump industry, it can still be very difficult to identify problems with equipment before it actually becomes a crisis. Now it's an emergency situation because a product's down. We have to get spare parts in immediately, align resources that may already have been tied up in other projects. And then also a retiring workforce. So we're kind of in a unique stage where we're seeing a lot of veteran workers leave the industry and a new generation shift in. And with that shift, a lot of system knowledge is lost, or what I would call tribal knowledge, where they have these tricks of the trade in their mind. It's not necessarily documented, and it's not being passed down. So with that said, a lot of the customers are addressing these challenges or pain points by moving to digital water or smart connected products. And we're seeing that with a 3 times faster growth in the digital water space compared to the conventional water technologies. Here are just some of the value that smart connected products bring our customers. First is asset management. Now you just have a database, a couple clicks of a button into an application that tells you what you have, where it is, when it was installed. A lot of times, tech support, a big portion of the initial conversation is just trying to figure those things out, right? What the customer has. A lot of times nameplates are worn out, IOMs were thrown away, so they can't quite figure it out. Now with just a couple clicks of a button, we already know what you have. We can get straight to troubleshooting or helping you out with your needs there. And also with startup and operation manuals, once again, you don't have to save pieces of literature necessarily or go digging through websites and struggle to find anything. Once again, a couple clicks of a button, you have those startup manuals and learning how to operate that product right there. Energy optimization, that's all around reducing life cycle costs with more efficient product. And then next is condition monitoring. So we touched on that in the previous slide, all around knowing what is the health of your equipment, but taking that a step further and getting some prescriptive maintenance, which is telling you what the problem is and some actions to take to resolve it. So with that said, with some of those high-level market trends that we're seeing and those customer pain points, it led us down this path. So our main strategy here at Xylem is focusing on some intelligent solutions and digitalization. So we'll be touching on the integrated motor VFD, which is the Hydrovar X here in the next slides, and wrap up the presentations also talking on the digitalization portion, which is optimized condition monitoring sensors. So high-level roadmap, just to give you an idea of what we're looking to do moving forward, is having a common user experience, user interface. Today we have several different variable frequency drives. Just because you're familiar with one doesn't necessarily mean you're going to be familiar with another one. A lot of them look and feel very different. They're using even different terminology to talk about similar features or functions within it. The idea is to eliminate that. So now whether you're working with one of our circulators, Hydrovar X, standalone VFDs, whatever it may be, they're going to all look and feel the same. And we're taking a similar approach with our mobile and web applications. So if we do have a few of them now, they still, once again, are going to look and feel the same across the board. So this slide here is just a bit of a reiteration of the previous one, just kind of showing you on the left-hand side here our handful, 7 to 10 different products that we offer today. As I mentioned before, they all look and feel different from each other. So just because you may be an expert in one doesn't mean you're an expert in another. And it really can overwhelm our internal teams and even customers out in the field becoming experts in this, because now we're trying to get them to learn a ton of different products, which can be very difficult to do. So the idea would be to consolidate down into 4 or so different products, but those 4 products have the same look and feel. So now if you're an expert in one, you're going to be an expert in them all. So it's just going to only help both our internal tech support teams and our external customers interacting with our product and become true experts in them. And to take it a step further, it also helps us from a supply chain standpoint. If we're leveraging some economies of scale, by using some similar components across the board, now we can lower cost, pass those along, and be even more competitive out in the market. And also with consistent design, we typically have a lot of projects in the funnel, overwhelming our engineering resources. By giving them some common building blocks, we can more efficiently use those resources, stay ahead of the curve, and continue to bring cutting edge technology out into the market for our customers. So with that said, jumping to the Hydrovar X, the full name here, a bit of a mouthful, but it's a permanent magnet assisted synchronous reluctance motor with an integrated variable speed drive. It ranges from 4 horsepower all the way up to 30 horsepower. And the idea here is just to simply pair this with all of the pump products that you guys are all already familiar with. And we'll touch on what products we're introducing this Hydrovar X platform with in the next few slides coming up. So range overview, there's going to be input voltage ranges from 200 to 240 volt or 380 to 480 volt with a plus or minus 10% tolerance on that. These are all going to be three-phase input, dual hertz, 50 or 60 hertz. This is a bit different than maybe what we're familiar with, but the different voltage ranges are actually due to the motors. So there's two different motors. There's 200 to 240 volt ones, 380 to 480 volts. When it comes to the variable frequency drive itself, it can actually accept the whole tolerance from 200 volt all the way up to 480 volt. So to give you an idea from a stocking level perspective, there's literally only 3 SKUs or part numbers associated with the VFD hardware. It's just a matter of implementing the right programming and software associated with those. And next, the motor itself has a speed range of 800 RPM to 4,000 RPM. So these are 4,000 RPM rated motors. TEFC motor. The VFD has a NEMA 4 enclosure rating, so they can be used outdoors. And then the temperature there, that is actually ambient temperature rating, so this can be in an environment from -4 to 122 degrees Fahrenheit and operate perfectly fine. There's 3 different frame sizes, as you can see along the bottom. There's a size B, C, and D with a few horsepower ranges, but as I mentioned, this can go from 4 horsepower to 30 horsepower. On the left there, we have a planned size A. That's a 1/2 horsepower to 3 horsepower product. We do have an offering in that space today, a permanent magnet motor with an integrated VFD. The idea is to refresh that product, bring the technology up to speed with the Hydrovar X, and now we'll have a single offering ranging from 1/2 horsepower to 30 horsepower.
We do have our first question, and the question is to clarify, did I hear correctly that you can use single phase 230 volt input?
No, strictly 3-phase input for the Hydrovar X products. The single phase offerings would be the size A that accepts the single phase or 3-phase from 1/2 to 3 horsepower, but that is a different product as it stands today. So if we're specifically talking Hydrovar X from 4 to 30 horsepower, it's 3-phase input power only. All right, moving on to some other features. So there is a color graphical LCD display on the unit. You can download the Xylem X mobile application. It's basically a handheld screen for you to use. We'll touch on that in more detail later in the presentation. You can do multi-pump applications up to 8 pumps without the need of an external PLC. A bunch of different control modes ranging from constant speed, constant pressure, proportional pressure, and linear or quadratic. Constant flow, constant temperature, differential temperature, and some differential pressure there. Communication protocols, so built-in standard to each unit, we are going to have Modbus RTU and BACnet MSTP available as standard in every single unit. However, there is a port in there where you can buy an additional module. It's an AnyBus module. It basically has any protocol you can think of, so if there's something different you need, we would just require you to purchase that additional module, install it out in the field. However, the majority of the applications are using Modbus RTU, BACnet MSTP, which is pre-built in or standard with each unit. Here, the top left is the primary market, primary applications for this. So I'm going to say that's not going to change. We are, as I mentioned earlier, pairing the motor and VFD, the Hydrovar X, with pump products that we already have established. So you're going to still use these pumps with the Hydrovar X in the same markets or applications that you're already familiar with using it. We're just improving our pump products and giving it some additional features, benefits that are associated with the Hydrovar X. The bottom left is just some screenshots of some of our competitors' integrated products. And then on the far right is a bubble chart basically balancing perceived price versus perceived benefit of the different product offerings out there in the market. Prior to the launch of Hydrovar X, I would say our Hydrovar X classic product, it's that bubble kind of floating up there in the middle, no man's land. I would say we had a bit of a high perceived price, but we didn't necessarily have the perceived benefit of the others in the market, as we didn't have a truly integrated product. We weren't at the higher efficiency levels. Where now with the Hydrovar X, we have certainly added a ton more perceived benefit, maybe even surpassing the majority of the competitors on the market there. and keeping a very competitive perceived price to them. So you can see that other bluish bubble there to move to the far right would be the Hydrovar X technology we're going to be talking about. So some key differentiators. The first is sustainability. This is a big one. So all the permanent magnet motors on the market, the competitor solutions, are using a rare earth material or magnet called neodymium. It actually takes large volumes of area. You have to extract very large areas just to get a very small amount of this neodymium material. The downside with this is it's very toxic and radioactive, so it can be harmful to both human health and the environment if not done properly. We are not using neodymium in our solution. We are actually using a material called ferrite. It is not toxic or radioactive, so from a sustainability standpoint, we certainly are a step ahead here. And to keep on that neodymium material, 90% of the world's supply is actually coming from China. So if there's ever trade disputes or restrictions in availability, hampering supply chain, we are bypassing that. We are not running into those types of issues. Ferrite is much more readily available, stable costs associated with that. And also, electric car manufacturers are using this neodymium in their electric vehicles as well. So highly sought after material. Availability and cost can drastically fluctuate. We are simply bypassing that and keeping everything much more stable for our customers. So moving to the next piece is efficiency. So the huge benefit with neodymium, that rare earth material, is achieving higher efficiency levels. So traditionally, permanent magnet motors reach an IE5 efficiency level. To give you an idea, standard induction motors that are used today are IE3 rated, or what we would call premium efficient. Any jump from IE3 to IE4 or IE4 to IE5 is a 20% gain in efficiency. So the perk here is we were still able to achieve the IE5 efficiency levels without using neodymium. And then the last box here is simplicity. This was a big one for us, a key point for us in the development of this product. We spent a lot of time here, got a lot of users in a room from varying experience levels, and just kind of looked over their shoulders, working with digital solutions, mobile phones, web applications, saw what was intuitive to them, simple to them, what was difficult, and designed our whole HMI software around that. So I think you'll find that our user experience with this is very, very simple to use. The product literally takes a couple minutes to program and set up, and you're off and running. Traditional VFDs, could take up to an hour or more to program. One of our other VFDs that we have, with a startup Genie, can take 15 to 20 minutes even with a startup Genie. This also has a Genie, but simply takes 2 to 3 minutes to get through everything and truly program. So far, a lot of the feedback of users getting their hands on these, they've been thoroughly impressed with the simplicity. So hopefully after running through this and seeing me go through some of the programming, you will feel the same and have that same response and feedback. Next is a compact design. The example I like to give, if you're looking at a traditional 15 horsepower induction motor, if you were to take that and look at our 15 horsepower Hydrovar X solution, the circumference of the motor and VFD together of the Hydrovar X is the same circumference of a 15 horsepower induction motor by itself. So the motor here is significantly smaller compared to a traditional induction motor, and with the VFD on there, you are still getting a more compact footprint. And if you're using something such as a multi-stage pump, being a 4,000 RPM motor and being much more efficient, we can take advantage of less stages with similar horsepower products, so we can even get our pumps a little bit more compact as well. And then lastly, serviceability. I think this is a big talking point and key feature for us as well. A lot of product on the market with these integrated solutions, if a VFD or motor were to go wrong, you have to replace the complete unit. That is not the case with our solution. We can separate the motor from the VFD, so if one or the other goes bad, we can simply swap out the component that is having the issue. And not only that, by taking the VFD off of the motor, there is still no unwiring or rewiring required from the customer. There is a quick connection port between the motor and the VFD. So you're simply unscrewing a few screws on the side of the VFD, and you can pull off that VFD plug there. So it's even quick and simple still to do some replacement or serviceability on the product. So we'll get into the rotor design on the next slide, but here the middle one is just showing you that expansion module. You can see it on the bottom right of the image there, that little gray module. That would be where you would buy that expansion module or communication if you needed something other than Modbus RTU or BACnet MSTP. So you would take the cover off the VFD, a couple screws for that module, but you would put it right in that port. The far right, I talked about it a bit already, maybe difficult to see on your screen, but you can get an idea of that quick connection port. It's a little triangular piece kind of there on the top of the motor. And you'll also notice that there's fins on the motor there. On the bottom of the VFD heatsink, it's also going to have a similar fin design. That is just letting adequate airflow between the VFD and motor to keep everything nice and cool during operation. It is utilizing the motor's own fan during operation to blow air between the motor and VFD. So here's 3 different rotor designs. The first one on the far left is a traditional permanent magnet rotor. So that whole thing there would be that neodymium material. As I touched on earlier, supply chain can be very complex. There could be high fluctuations in cost and availability. There's also a very high environmental impact with it being toxic. However, the benefit with that is you get much lower energy consumption or those higher efficiency levels we were talking about at IE5 rating. The far right is a typical induction or reluctance one there. So stable supply chain, very low environmental impact. And then the middle is our Hydrovar X design. As you can see, we've taken a bit of a hybrid approach. So we're not using that neodymium, we're using ferrite. We have a much more stable supply chain and a very low environmental impact associated with that. However, we're still achieving those lower energy consumption levels or those IE5 efficiency levels that are seen with permanent magnet motor. Here are some screenshots of the Hydrovar X. So the far left is of the HMI itself. The right are the mobile application, but you'll notice that whether you're looking at the HMI or the mobile phone, it is going to look the exact same. So whatever you can see and do essentially on the HMI, you're going to be able to do on the mobile application as well. But here, I like to just point out, it's almost like a mobile phone itself. You can see that a few dots going along the bottom of the HMI screen. That's like multiple home screens that you can navigate between. Each one's going to have a bunch of widgets on the screen or main home screens with valuable information. But you can also click on the widgets and interact with them and change settings right from there as well. So the majority of the time, you may never have to go beyond these 4 or 3 home screens there, right? You can look at the valuable information on the widgets. If you're seeing something you don't like or you want to adjust, you can simply do it right there. So you may never have to go beyond there and dive into the sub-menu groups and potentially get lost or overwhelmed with however many parameters or settings are available to you there. So the Xylem X app, that is the name of the application if you want to go ahead and download it. It's Xylem X. That's going to be the Hydrovar X mobile application. As I mentioned, it's basically an additional display. So if this is in a restricted space, so you just don't necessarily want to bend down to program the unit that may be on the floor or something of that nature, you can connect to the Hydrovar X via Bluetooth, use the mobile application, and you'll be able to configure and even operate the unit from there. Within there, you can also get some user guides to help troubleshooting. You can generate service reports, send it to somebody. 2 kind of key features with the mobile application is you can download and upload parameters in a CSV file. So what's that's going to do is if you're having issues out in the field and you just can't quite figure it out or you don't know what parameters were changed, you can send this to our internal tech support teams. You download this CSV file. It's basically just a parameter dump. They can review it. If they catch something that looks out of the ordinary, they can adjust it, resend you the CSV file, in which you can upload back into the VFD, and hopefully that resolves any issues or problems that you were seeing with the application. Or also, if you have similar applications that you would need to set up, you can simply use this CSV file to download it, upload it onto another one, so you can bypass kind of the Genie process and simply just update these parameters to another VFD. And then lastly, upgrade the Hydrovar X firmware. So for a lot of VFDs, you have to plug into it, have a special computer application to log into to perform some software updates. You can do this now through the mobile application. You would simply, once again, connect via Bluetooth and update that firmware from the mobile phone. And a question we typically get is, a lot of these equipment is installed in places without cell service. The idea is here you would download the Hydrovar X firmware on the mobile application or obtain it while you have cell service. Then you can go down into said mechanical room or basement, wherever it may be, that has limited cell service, and still download that firmware via the Bluetooth connection. So you won't necessarily have to worry or be concerned about having proper cell signal. So 3 different apps that we have available to you, whether it's the Optimize app, Xylem X, which is the one we just touched on a bit, that would work with the Hydrovar X VFD, and then Avener. But if you already have a username and login for one of these, it is the same across the board. Or if you download Xylem X today and it's your first app, you would need to register for it. And then in the future, if you ever downloaded our Optimize or Avener app, you would just still use those same credentials to get into those other applications. So here's how you would connect the unit, the mobile application, to the Hydrovar X via Bluetooth. There's what I call a multi-function button on there. It has 3 little dots. You would long press that for a few seconds. Once you long press that, you should see an LED on the front of the Hydrovar X drive that will start to flash blue, letting you know that it's essentially in pairing mode. You would look on the mobile phone. It should pop up any units that are in that pair mode around you. You should see a serial number. On the side of the VFD, there is a nameplate sticker that would have the serial number there. You just want to make sure it matches to the one you're selecting or trying to connect to. A 6-digit PIN will show up on the Hydrovar X screen. You would type that into your mobile phone, and it will make the connection for you, and then you'll be able to operate, configure the unit through the mobile application there. So another neat feature, I like to call this basically like an embedded IOM inside of the Hydrovar X. So as I touched on before, a lot of VFDs or manufacturers use different terminology for similar functions or capabilities. So you may not necessarily be familiar with everything in the drive, or if you're just a new user to the VFD, if you're not quite sure what something is, you have the ability to hit an info button, and it's going to give you a pretty detailed description of what exactly that function or feature will do for you. So you don't have to go digging through an IOM, call tech support, or anything of that nature to try to figure out what a control mode is. Like I said, there's simply an info button, and you get a pretty detailed description of what that said control mode or feature is. So here is Avener. Avener is basically its own standalone product. It is a remote monitoring solution. It's a web-based platform. And what it can do is tie into all of our variable frequency drives and give you that remote monitoring capability. You can check the status of your application, the VFD, see if the pump's running, if it's off, if there's alarms. You can do some writing capability or control capability of the product. You can turn it on and off remotely. You can change some pressure set points if you need to. This is almost basically like a BMS light system, so it not only can monitor our variable frequency drives, but really any piece of third-party equipment that has Modbus capability. You would just simply put in the points table into the application, and then you would be able to read or write whatever that specific product allows you to via its points table. However, if you're using one of our products, whether it's the Hydrovar X, IPC, they will be pre-programmed into the platform for you to simply say, I want to connect to this, and those point tables behind the scenes are automatically auto-populated for you, so you don't necessarily have to do that work. So here are some screen grabs from the Hydrovar X platform. It's just going to show you in graphical representation all the data that's ever been taken. So the top left one there is just energy consumption that it's used. You can see the actual pressure of the system at any given time, the speed of the unit, and there's plenty of other charts and graphs that you would be able to navigate and see. Here would be the main dashboard of the live data. So if you didn't want to necessarily just look at the historical trends or data that's happened, and you just want to see what is specifically happening right now, you would go to the live data tab. You can see here we have a triplex Hydrovar X system going. There's 3 different pumps there. 2 of them are ready to go, but you'll see their speeds are 0. They're essentially in that standby mode. And then pump number 3 is running, and you can see the speed and pressure of which it's running at. Next, this is the main dashboard that you would see upon logging into Hydrovar X. It's just going to tell you the number of stations you have, any active alarms. So maybe this would be as far as you go. If you don't see any active alarms, you got your peace of mind. There's no need to necessarily maybe look into the sites or stations to see what's going on. If you do have any alarms, maybe that's when you would navigate into that specific station and look at those graphs or live data or specific alarms of what's going on there. And then here is just a screen grab of the Hydrovar X implemented on a few different of our pump product offerings. So the far left would be the ESH, or which anything that has the Hydrovar X product, there's an X added to the end of the name, so that would be the ESHX. The EHVX in the middle there, one of our packaged systems, and then the right would be the EHM product. So I'll pause there for a second just to see if there's any questions, comments on the high-level overview of the Hydrovar X. Good. All right, we'll keep going. So now just to talk about a bit of the pump products we'll be introducing it on. So I'll be filling in here, but this is the ESV, EHM. So these multi-stage products would fall under Gretchen Valentino, but we are introducing the Hydrovar X product line on them. So starting with the ESVX, here we're not fully utilizing the full range of the ESV product. As I mentioned before, the Hydrovar X stops at 30 horsepower. The ESV can be utilized with up to 75 horsepower motors, so there is some limitation on the full product portfolio we can take advantage of with the Hydrovar X solution. But the ESVX then would give you flow rates up to 600 GPM and head up to 1,100 feet of capability there. A lot of the other key features as far as the liquid temperature, maximum pressures and things you can use is going to be the same as the ESV that you're using today. Like I said, just the only cutoff is going up to the 30 horsepower range. So here at the family curves, you can utilize this still on the 1 SV all the way to 125 SV, but forward to 30 horsepower. And these are the family curves giving you an idea of the flow and head capabilities of each specific range within the ESV family. Similar, the EHMX, we can actually use the Hydrovar X basically across the whole range here, but you're getting gallons per minute, 130 gallons per minute, and 540 feet of head max. Still same working pressures that you're used to with the EHMX, but similar. Here's some family curves to take a look at. You can use this on the 3HM to 22HM product family. 4 to 7.5 horsepower. So this does include the complete range we can cover with the Hydrovar X. Moving on to centrifugals. So this is the ESH or ESHX when utilized with the Hydrovar X. This would fall under our product manager, Jimmy Wood. Similar here though. All the key features and benefits that you're used to with the ESH, none of that's changing, right? You still get the 316 stainless steel construction. It's that close coupled design. You got some mechanical seal options available to you. But here we can take advantage of that full 4,000 RPM range here. So if you're looking at our performance curves, they could look a little bit different. We show you, multi-speed curves all the way from 3,000 RPM to 4,000 RPM, but we still kind of labeled that 3,600 RPM as 100%, as that's what customers are traditionally used to seeing as the full speed of a product. But like I said, we can essentially overspeed the ESH up to 4,000 RPM due to the motor's capabilities. So we're showing you those curves as well. With this, there are strictly 12 pre-configured modules. So I know if you're looking at a normal ESH, there's plenty of different impeller trims that you can choose from, or even do custom impeller trims. With this, they're just picking a couple different max impeller trims, and you're utilizing the capability of the Hydrovar X to slow down to cover a wide range there for you. So with that said, that equated to 12 different pre-configured models that will be available to you. And then lastly, the package systems, so the EHV X, and then a bit of a newer product, EHV XR, which is just a little bit of a twist on the EHV X. So here, if you're familiar already with our package systems, right, you're just getting everything mounted on a skid. It could be a duplex, triplex, quadplex, all mounted on a skid. We're giving you the manifolds, valves, gauges, so on and so forth. You'll have a panel on the end. It's a single point power panel there. You can decide what end you want it on. If this has to be in a certain spot for a mechanical room or space, you can choose the left side or right side for that panel to be installed on. But much simpler and easy to navigate and use with that Hydrovar X HMI now and that software compared to the historical 5th generation Hydrovar that these packages used. So here, the EHV X is simply a direct replacement to the existing EHV. However, we did expand on the range. So if you're familiar with the EHV product line, they did max that offering out to 15 horsepower range. With this, we are going all the way up to the 30 horsepower range, now expanding that. So the EHV X now can be offered all the way up to the 125 SV, giving us 800 gallons per minute max range and 2,100 gallons per minute max range. And we haven't touched on Avener. Optimize will touch on a bit, but these packages will actually come standard with the Avener gateway in the panel and optimized sensors mounted on the ESV pumps of the package. And then the EHV XR here, we were getting a lot of feedback from customers out in the field, especially retrofit opportunities. A lot of these packages go into new designs, kind of walls aren't quite up yet. It's easy to put them in a mechanical room. But after that, the building is completed, everything's kind of closed in, and it was tough to get new packages into those buildings. A lot of times we were finding customers having to remove manifolds to get these skids through doors and then putting the manifolds back on, which is not the idea that we want of selling packages, right? The idea it's all done for you. So what we've done is created the EHV XR. Now the suction and discharge manifolds are on the same side of each other, right? You can see them on top of each other there, giving us a 30% reduction in footprint. And the whole idea here is now if you're using this R configuration, these will fit through a standard doorway for you. So now you can get them into those tight spaces. You don't have to do some work out in the field by taking off the manifolds and putting them back on. Here, though, we do not go all the way up to the 30 horsepower. These R configurations are strictly up to 15 horsepower, and we'll be utilizing the 5SV, 10SV, and 15SV models. But similar to the previous slide, this will still include that Avener module and optimized sensors as standard on the package. And then lastly, sizing and selection tools. So everything that you saw was launched except the EHV packages. They're still going through finalizing some of the details on those packages, getting them implemented in the sizing tools, wrapping up some literature. So we don't expect those to be launched until mid-August of this year. However, if you're looking for the ESVX, EHMX, ESHX, those are ready. They can be purchased today. We have them already available in our sizing and selection tools for you to size, configure, get some submittals on them. And that is on our Xylem Solver tool. So any questions with the specific pump products? Okay. So we'll get going into the basic alarm and error handling. I just like to touch on this. You'll see it once we get to the hands-on portion. But there's two different types of faults, essentially. There's alarms and errors. Alarms are less critical. They're going to be shown on the LED as a yellow flashing light and is a non-blocking condition. So what we mean by non-blocking is it's not going to stop operation of your system or your pumps or motors. What's going to happen is it's just going to notify you something is wrong and you need to take a look at it, but everything as far as operational standpoint is still going to remain active. An error is a blocking condition, so that is more critical. That is actually going to shut down your unit and need some manual intervention to fix it before it's up and running again.
So we do have a question, high level, can we use this technology on other pump brands?
Yes, this is a question we get a lot. So the idea was we are basically trying to start to sell this on our own products. However, this fits in traditional NEMA dimensions, and nothing is necessarily restricting a user from using this on competitors' products. So in short, the answer is yes, it can be.
Quick follow-up question to that. What about retrofits on existing Xylem product in the field?
Yes, once again, that is something that can be done. We want to, I think, be able to help customers and give them kind of guidance on how to do that. As I said, this is a 4,000 RPM motor that's a bit efficient, so it's not an apples to apples 7.5 to 7.5 horsepower replacement, right? There's some additional benefits, so we just want to make sure you're going to make the right selection doing that. So always just reach out, at least initially. We're trying to work on creating some white papers to help you out with that, but once again, in short, the answer is yes, it can be done. Just need to get some guidance from the factory. Okay, I'm circling back. Like I said, an error is a non-blocking condition. It's going to actually shut down the unit and require somebody to resolve whatever that problem is before it will become operational again. To avoid nuisance tripping or to prove a fault, an error will actually try to reset itself a few times. And if it fails after a few failed attempts and it continues to see that error, that's when it completely shuts down the system. But it will try to reset itself a few times, and after the third time, if it has failed, it's going to shut down the unit just to protect it from not damaging itself. There would be an alarm list, so you can find this in the IOM. You'll actually also be able to find this right on the VFD HMI itself. But any alarms, like I said, are going to be indicated by a yellow flashing light. They're going to start with an A code followed by 2 digits. And associated with that, you have a name, description, and potential solutions on how to fix what the alarm is. And then similarly with errors, they're just going to be, you'll find what they are by a flashing red light. There'll be an E code for error followed by 2 digits, and similar structure again, name, what the description of that error is, and some solutions on how to resolve it. So that's all I have as far as slides. I will fire up the Hydrovar X units here, and we can kind of get some hands-on going. But in the meantime, once again, if you have any questions while I'm doing this, it'd be a good time to ask any questions before we jump to the next stage of the training here. Oh, well, I can leave it on. So to start, we have 2 units here side by side. One of them we have the cover off just to show you the wiring of everything. So the front cover would come off. There's 4 screws. You'll take it off. You can see you have ample space here to kind of get your hands in there for ease of wiring. But your power wiring would come in through here. You would have an L1, L2, L3, and a ground. We can see them all wired up here. Each unit is going to come standard with a 0 to 300 PSI transducer, 4 to 20 milliamp, and it will be an analog input 1. So this cable you're seeing here is the transducer cable. And if you were going to run a multi-pump application, we have a bunch of RS-45 or communication ports here available. So this would be for multi-pump. We have it showing here, for example, it's going out to the next pump. But a nice thing about our communication wiring, we have a ton of different ports. So a lot of VFDs on the market, you have to choose between multi-pump applications or BMS communication. With ours, that is not the case. We have 2 different banks here. One's available for multi-pump, so terminals 28, 29, 30 are for multi-pump applications. 31, 32, and 33 are available for communication to BMS or SCADA systems there. So you don't have to choose. You can do both BMS communication and multi-pump capability. And on top of that, we have a secondary bank here. So once again, in a lot of different VFDs, if there was more than 2 pumps in the system, you would need to have wiring coming in from VFD number 1, and then wiring going out to the next VFD, and you would have to cram multiple wires into these small banks. We have an additional port. So basically we have incoming and outgoing wiring available. So just a ton of different RS-45 communication terminals available for you, just to keep that ease of wiring nice and simple for users out in the field. But moving on to the HMI itself, so we have this unit powered up. We'll go over here we just have the basic navigation buttons, up, down, left, right. The center button is your enter button. That's how you're going to confirm or select any parameters that you want. This is that multi-purpose button or multi-function button I was discussing. That will get you into the menu group if you wanted to go beyond the 4 main home screens. Here is a on-off button. So although it has that power symbol, it is not actually going to cycle power or turn off power going to the unit. This is simply just going to start or stop operation of the pump and motor. So that is a start and stop, not a power. And then lastly, we have a few LEDs. So this top LED is simply power. If you have power coming into it, that should be lit up green. Obviously, your LCD should be lit up as well if you're getting power. But in the event maybe the LCD is damaged or not working, I guess this LED could be an indication of that. If this is still black and you have this green lit up, that's a potential issue of the screen itself. The middle one is a status icon, so that's going to tell you any alarms or errors. So this can light up 3 different colors. If you're seeing red, which you're seeing now, and I know what that is, we'll touch on that once we get going, but red is one of the errors. That's a more critical thing that's going to prevent operation of a unit. Yellow is an alarm, which is less critical, but that'll still keep your system operating. And then if this is flashing green, that means that your motor is actually running. So there could be a case this is alternating between green and yellow, notifying that the motor is running, but there's still some sort of issue that you would want to look into. And then the last LED is your communication LED. So this will light up 2 different colors as well. It'll be green if you are communicating to a BMS or SCADA system. It'll be blue if you're connected via Bluetooth with your mobile application. And there could be times where you have both going. So that would alternate between blue and green if you are connected via Bluetooth and a BMS or SCADA system. So here, upon startup or initial power up of the unit, you're going to get this welcome screen. You have 2 options. The first is saying to press the enter button if you want to go through the setup or startup genie. And the second one's saying hit the multi-purpose or multi-function button if you want to bypass the genie and just go directly to the home screen. Since this is a brand new unit, we're trying to install it in the field, we're going to go into the genie. The first question is asking you language. So we have a ton of different languages. We're going to go English US. Different pump modes. So we have single pump. Then there's 2 different multi-pump modes, serial cascade, synchronous cascade. So the difference there is serial cascade, the last stage pumped on is going to run at variable speed. All the other ones are going to run at full speed. So if you had 3 pumps in the system, let's say pump 1 turns on, it's going to run all the way to full speed. If it is still not meeting your demand, it's going to call for pump 2 to turn on. Pump 2 is going to run full speed. If it's still not meeting demand, it's going to call for pump 3 to turn on. And then pump 3 is the one that's going to ramp up or ramp down or up to maintain your set point, while pumps 1 and 2 continue to run at full speed. Synchronous cascade, bit what it sounds like. So all pumps in the system are going to run at the same exact speed to maintain the set point. So they all will speed up and slow down at the same exact speed to maintain your set point. So the difference there is serial cascade is a little bit more accurate at maintaining or hitting a pressure set point. It's not going to overshoot or undershoot, as one single VFD is ramping up and down. Synchronous cascade is a bit more efficient. So now you don't have multiple pumps running at full speed. They're all running at a reduced speed. You're going to have a much more efficient application. However, it's a little bit less accurate. You may see a little bit more overshooting or undershooting of your set point initially when it's ramping up or down. However, if it's not really a critical application, we would obviously recommend synchronous cascade just to get a little bit more efficiency out of your application there. But here, we're just going to go with single pump. So we'll do single pump here, saying let's set some important parameters. We'll just click enter to go through there. So here now it's just asking, do we have pressurization or circulation? So basically pressurization is your open loop applications. You're just trying to maintain essentially a constant pressure. Circulation would be more of an HVAC type system, a closed loop system where maybe you're trying to maintain some differential pressure or something in the system. So here, for our case, a lot of times we're just simply using pressurization applications. So we'll go with that. And then a bunch of different modes. We touched on them before, but constant pressure, proportional pressures. You can see your constant flow, temperature, level. We'll go with constant pressure. And then units, SI units or imperial. So I clicked imperial. Now it's saying, do those units look good? And if you don't like something and you still want to tweak them, maybe they all look good, but instead of seeing pressure in PSI, you can click on it and say, no, I'd rather have this in feet ahead. You can go ahead and cycle through. There's a lot of different options. We'll keep it on PSI, but similarly, you can go through any of these and adjust them or fine tune them if you didn't want that specific unit of measure. But if it looks good, you go back up to OK, continue. Now this is saying the full scale of the sensor. So it's basically just asking what sensor you're using. It's going to come preset at here, populated at 300 PSI. As I touched on, we are including a 0 to 300 PSI transducer. But if you had a higher pressure application and you were going to end up using a 0 to 500 PSI transducer, for example, then you would need to adjust this up to 500 PSI to let the unit know the full range of the sensor you're planning on using. Or you'll get inaccurate pressure readings back to the VFD then. Next is your set point. So we can adjust this for keeping it simple math-wise. I'm going to go with a 100 PSI set point on here. So we want to maintain 100 PSI. This is what we're telling it. And then the next question is the start value after the unit stops. So this is percentage based. So basically this is saying once this VFD has satisfied demand and it's turned off, right? It's slowed down, went to minimum speed. It's proved out that it's still meeting demand and there is no demand in the system. It's going to trigger the unit off. So now when is it going to wake back up? So here it's saying 100% basically means as soon as it drops to 99%, it's going to kick back on. Obviously, we probably want some sort of buffer. So if I go to 90%, that's basically going to be a 10 PSI drop. Once the system demand kicks on, once that system pressure drops to 90 PSI, it is going to call this unit back on to maintain the 100 PSI set point we have. Minimum threshold, this is essentially, I'll call like a minimum or a broken pipe feature. So you're going to set a PSI that you want this to go to. Let's just say 30 PSI, for example. And then there's going to be a delay time. So basically it's telling you how long should it take me to get to that 30 PSI. So if I set this to 10 seconds, it's telling the unit, if I don't achieve that 30 PSI you set in 10 seconds, I'm going to kick off because I'm assuming something's wrong. And that would, my example is that broken pipe. So let's say there's a broken pipe on the discharge. If you don't have that minimum threshold set, the pump is just going to continue to pump, try to ramp up and hit that 100 PSI, and it's never going to because there's a pipe broken and we're flooding a facility. This is just going to capture that. It's saying, oh no, I'm not getting to where I need to be in set amount of time. Something must be wrong. I'm going to turn off to prevent some sort of disaster like that. And then pipe filling mode, so if it's a brand new system, you can bypass a couple alarms just to let it know that it's filling pipes, and it may still take some time to get up to pressure to do that. But if it is already an established system, you're not looking to fill the pipes, you can just keep this disabled. And then we're simply into date and time, which this is actually correct, but you adjust that accordingly. And then time. And after that, it's just a system preview telling you what you selected the Genie, so single pump, constant pressure, analog input 1, it's defaulted to that pressure sensor. And if everything looks good, then we can continue. And here now it's just going to give you two options. So if you're really ready for the system to operate and kick on, you can click the power button to let that motor turn on. If you're not quite ready for the system to turn on, and you just want to save the parameters, you would click the multi-function button to go to the home page. So I'll say that we're ready and can go. So I hit the power button. This is a demo software, so it is showing, you saw it ramp up to 100 PSI there. And it's still giving us critical system information. Single pump, constant pressure. I'm showing that error, so the red light here is telling me there's an error E11. I can click the enter button, and it's going to give me a date, time. But if I click over for info, it's going to tell me what E11 is. So it's a sensor 1 error. It's not getting an analog input reading from the sensor, which is right. We don't have a transducer wired into this right now. It's expecting to see one, so it's not getting that 4 to 20 milliamp signal. It's seeing 0, so it's letting me know that there's something wrong with my sensor. As I touched on, there's kind of widgets you can mess with on the various screens. So if I scrolled over to the next one, this is your pressure set point. So if you wanted to adjust this, I would click enter on it. I can reduce the set point to 90 PSI if I needed to right on the fly from the home screens. The next one is auto start. It's just if you want that system to automatically start itself or not. It's kind of like manual mode or not. We're going to put it in auto so it responds by itself. And then that start value. So once again, if you were seeing too much of a pressure drop and you wanted to tighten that window, we can increase this to 95% now. But it's also giving you some valuable information on this screen. So it's telling you the required value. So that's what you have your pressure set at. This is the current motor speed. You can see that fluctuating as if it's slowing down or speeding up to maintain the constant pressure. There's runtime. Something else I can show you, so if you were to connect your mobile application, as I mentioned, you can long press the multi-function button. After a few seconds, it's blinking blue, so it's telling me now that I can find it on the mobile application and pair to the device if I wanted to. A couple other things, so if you wanted to get into the menu button, once again, you just click this. There is a password to get into the menus. The default password is 066. To get in. You do have the ability to change that. If you went down to general settings, security, password entry. No, that's not what we want. You can set the password. So here it's set at 66. This is where you would go in and change the password. Basically, you can do any number from 0 to 999 as a password here. Key lock, you can tell what the password does. So right now it's just to simply get into the main menu group, but this key lock, so right now it says no. You can change that to yes, so then they can't even navigate. If they were back on the home screens, they wouldn't be able to navigate even between these and adjust these. So just giving you a little bit further password protection on the unit, because right now it's strictly just simply to the menu group, but ideally, you may still want it at this stage where people can't come up and press or change anything. Another thing is you can't necessarily get back to the Genie once it's done. The one way around that is the home menu application. All of these questions are the same exact questions that were found in the Genie. It's just that it won't be guided in this standpoint, you would have to go into each one individually and reset them. But that is essentially the Genie parameters if you wanted to go back and change things. If you truly just wanted to start over and go through the Genie again, what you would have to do is once again go down to General Settings, Factory Settings, and there's something called Commissioning Complete. So right now it says yes. That is because I went through the Genie and completed that. I would go into there, change it to no, and once I switch it to no, I would have to cycle power to the unit, and upon powering back up, that Genie would ask me if I want to go back to the Genie. If you simply cycle power without switching this to no, it's just going to go right back to the home screen because it understood that you've already set the parameters to the Genie. Another way is factory restore. So if you switch this to yes and cycle power, it's going to wipe out any parameters you set and put it back to our factory settings. So a lot of times this is almost our first recommendation. If you're ever having issues with a unit and you just can't quite figure out what went wrong, or you're not sure what parameters somebody changed, do a factory restore, go back to the Genie, and a lot of times it'll fix many of the issues you were running into. So the difference there is commissioning complete. If you just switch that to no in cycle power, it's going to keep all of your previously saved parameters that you had. Factory restore is going to wipe out everything, but both will essentially reinitialize the Genie and let you go through that again if you were to activate those. Communication is where you would set these. So a question I get quite a bit is about the Bluetooth connection. Can we turn them off? So here under wireless communication, enable wireless connection. I can switch this to off, so now Bluetooth will not be activated. And as we showed you earlier, the menu group is password protected. So someone still can't just come on and flip this back to on without knowing the password that's set on the VFD. Some shortcuts. So here, right now we have the unit standing up, but if it could be on a horizontally mounted pump, so you could be standing on this side of the pump or this side. We have the ability to long press the enter button and up button simultaneously. By doing that, it flips the screen 180 degrees, so depending on what side of the unit. And by doing that, now the screen's the opposite way. This would technically be my up button, right? It's associated with the screen. So if I wanted it back, I'd now hold the enter button and technically the up button simultaneously still. And it flips back. Long pressing the down button, so we don't have a multi-pump system right now or something that's truly activating, but this is going to force alternate. So you're always going to have a lead pump in a multi-pump application. By long pressing this down button, it's going to force alternation and put the next pump in line as the lead pump. Don't. So the other feature I like to show, just diving into a random mode. So like I said before, if we were just unsure what one of these control modes does, you can be really in any parameter group. But if you're not sure, you would click this right button on them. You can see there's multiple screens here. It shows 2 blue dots. Going to the second screen, that is where it's going to give you much more details or descriptions on what each specific control mode or parameter does. So if you're just not quite sure, hit the right button, go to the next screen, and it's going to give you a bit more detail and hopefully help you out in figuring out what each thing does. I think that's it. Any questions on the HMI or software portion before we switch topics?
So I think the first question is a clarification. What are the onboard communication protocols?
Yeah, Modbus RTU and BACnet MSTP. So we can see them. Here are your 2 options, Modbus RTU, BACnet MSTP. You would click into them, and there's just a few settings that they would have to set up to match with their system. But those are the 2. Like I said, there's expansion modules available by taking off this back cover. You would see the port there to plug in to support really any protocol, but standard right here, Modbus RTU, BACnet MSTP.
Expand a little more on the additional AnyBus protocol for if you have to tie into a SCADA system where the facility doesn't have the Modbus or BACnet that you mentioned.
Yeah, so to keep it simple, it's really just a third-party module. AnyBus is the name of the company or the module. They have a bunch of different protocols. So basically, the simplest terms, like BACnet MSTP or Modbus RTU is a language, right? So that's how the two machines communicate to each other. They need to speak the same language. So if a customer's system that they already have in place doesn't have Modbus RTU or BACnet MSTP, we're basically buying a language card so the two units can properly communicate to each other.
And then last question, you mentioned the password protection and the ability to turn off Bluetooth. Can you do a quick demo of how you would lock this out so an end user doesn't have the ability to get in and change parameters?
Yeah, so those general settings. So right out of the gate, you're always going to have, I think it's because it's time, so we need a delay here since I've been continuously playing with it with the thing. But anytime you go into the menu, usually initially it's going to pop up that password. I did it on the start of the training here with this. But since I've been keeping my hands on the buttons and activating, I think there's like a 30-second or more timer before it actually locks it back out. But anytime you go into the normal menu group, it should ask for the password. However, at factory security, you can set password. I won't change it, but I'm not going to really change it, but you can change it here to whatever you want. We're going to leave it at the 066. Key lock, so there's no, yes, and password. So once again, I can go over for more descriptions. We'll do yes, password. We may have to sit for a bit. I'm not quite sure what the timer is, so let's just give it a few and see. But ideally, the way I switched it now is anytime a button, the first time I hit a button, it should require me to put a password in to do it. I just need that password default timer to initialize.
And then one final question before we get into the next piece, enclosures. What are the enclosure ratings that this is able to accommodate?
NEMA 4, so standard NEMA 4. There's no other enclosure options available for this, so any unit you buy is going to have that NEMA 4 rating, and it'll be outdoor usable. Let's see. Oh, maybe the timer's longer. But that's how, there is a, let me see if, there I logged out. So there, now it's requiring me to do the password again, which is 066. But like I said, you have the ability to change it. All that is done under menu group 9 and security. And you have your few options there. And by hitting log out, that's going to bypass that delay timer I was talking about.
An additional question, which is an extension of the enclosure question. Do you need to oversize if mounting in direct sunlight?
Yeah, if you're not, well, it's all about ambient temperature rating. So if you're exceeding 122 degrees Fahrenheit, that's the max capability of the VFD, then you would need to start to oversize there. The only concern also with direct sunlight is actually the screen itself. So this you can spray water on it, you can get snow, ice, whatever it may be. The screen is the only concern. If it's going to be exposed to sunlight, direct sunlight for long periods of time, it could just limit the life of the screen. It could start to fade and eventually go black. So if you're going to be in a sunny area, we would just recommend some sort of little bit of shade cover over the screen to prolong its life.
If the screen does fade out due to sunlight, is there the ability to replace just the screen, or do you have to replace the entire drive?
No, you can replace the screen. So to get to the screen, it's actually the 4 outside screws. You would take this off, and then more of the cover comes off. and you can simply unplug the screen and purchase a new one to plug it back in. All right, we'll switch over and talk about optimize, but if you still have any questions of Hydrovar X while we're getting the slide deck up, please feel free to send them and we'll get those answered. All right, so now moving to optimize. It's our condition monitoring sensor here. We'll go through just a couple high-level slides that I like to show. So first, when it comes to maintenance, this is called a cost iceberg. So similar to an iceberg, right? Only a little portion of that iceberg you can see above the surface, but really there's a whole lot more under the surface. So similar to when it comes to maintenance, a lot of people just only look at the direct costs associated to that, whether it's labor, materials, and kind of overlook safety risks or higher energy consumption from a product as it starts to deteriorate and become less efficient. Environmental issues, if something fails, could be harmful to the environment.
I want to circle back and ask one more question regarding the Hydrovar X. So if you are using a 50 hertz electrical input, can it still hit 4,000 RPM?
Yes. Yep, that doesn't change. Oh. So moving to the next slide. It's just the total cost of maintenance. So here's what I view as the three main maintenance strategies out there that customers or users typically, the approach they take. So first is being corrective maintenance, that is fix it on failure. So they're essentially waiting for the product to completely fail. It is no longer operational and action must be taken to get it back up and running. A lot of times that becomes, once again, an emergency type situation. They need to get this product back up and running. They're trying to expedite parts, allocate resources to this to give it attention. On the opposite end, we have preventative maintenance. Preventative maintenance is almost trying to maximize uptime and keep that product operational. So what they're doing, for example, is changing out seals every 6 months or so. So even though that seal may not be bad and it still is perfectly good, they're just changing out every 6 months because they know it's going to last that long and the product's not going to fail. And then predictive maintenance is taking the approach of actually changing out components based off of their condition or health. So comparing all three strategies here, corrective maintenance can be up to 10 times as much as predictive maintenance. And if we're looking at preventative maintenance, that can cost up to 5 times as much as predictive-based maintenance strategies. So here we have a PF interval chart, just kind of giving you the whole ideology behind the optimized sensor or condition-based monitoring solutions. So P stands for potential failure. That's that green star. A brand new product may be anything to the left of that green star. We know it's perfectly healthy. The components are good. It's going to operate. But over time, it starts to slightly deteriorate, and that would be that any point to the right of that green star, right? It is starting to wear a little bit. But we still have months, weeks, days for the product to operate. And then we have F, the PF interval. That's a functional failure. That's that red star. That is when an asset now is completely failed. Action is needed to get it back up and running. It's no longer operational. And those are kind of the 2 points where I was saying preventative maintenance is done or corrective maintenance, where the idea of predictive-based maintenance is putting on some sort of sensor that is monitoring your asset. In this case, optimize is monitoring changes in vibration or changes in temperature. So now that we know there is actual wear and tear on specific components, but it's giving us early warning indication. It's capturing it enough ahead of time where we have weeks or months, maybe days to take action. Now it's not such an emergency or rush. We have time to order parts. We have time to get our resources allocated and put them on the job to fix this asset. And on top of that, you can see the blue and red lines going across the chart here. So the blue line is just showing As we let a problem continue to get worse and worse, or components start to deteriorate more and more, it becomes less efficient. It's consuming more energy now. And also, as we let a problem get worse and worse, typically the cost to repair it becomes more as well. So just some more benefits or cost savings in capturing these things ahead of time is you're going to save yourself quite a bit of money just from an efficiency and cost standpoint on the maintenance side. And we also want to do it while they're deteriorating, where preventative maintenance, we may find ourselves changing out parts that are completely fine and we're throwing away completely good components. So here is a high-level system architecture of the optimized solution. The bottom there, you can see two kind of exploded bubbles. The one on the left is the optimized sensor itself. In this case, it's mounted on a bearing housing, for example, so that's where they want to monitor the temperature and vibration changes. That is going to communicate out via Bluetooth as standard. And there's two ways it goes out. The main method or initial way would be just a user downloading the optimized mobile application on their cell phone. It could be any iOS or Android device. And they would have to come within Bluetooth range of the optimized sensor with their device to collect the data. And then with their own cell service or Wi-Fi connection, it is going to push out the data to the cloud, which in turn can update other users' mobile applications with the most up-to-date information. The other way is if someone doesn't want to make maintenance rounds, or it is in a truly remote area, we can introduce the optimized gateway. So this is replacing a user having to come within Bluetooth range. You're going to mount the optimized sensor within Bluetooth range of the optimized sensor. It's going to collect the data via Bluetooth once again, but then that gateway is going to have its own essentially cellular subscription that is going to push out the data via LTE-M once again to the cloud and update all the users' mobile applications. And then up top, you can see the cloud, but then we also have that standalone product, which is Avener, which we touched on the previous slide deck. That's our smart monitoring platform, which not only can monitor VFDs, but it can pull in the optimized data. So optimized does not necessarily have its own web-based application. It's strictly a mobile application. So we're utilizing Avener as that web-based platform, and also that kind of BMS-like application I was talking about, where all of your equipment's information now can be funneled into a single dashboard or application for you to use. And then lastly, the bottom bubble there is showing you a Bluetooth pressure sensors. So now if you want to monitor suction pressure, discharge pressure, or have two sensors and monitor differential pressure, you can install those in the system. Those Bluetooth sensors are going to communicate to the optimized sensor via Bluetooth, and now you're going to get temperature, vibration, and pressure data. So here is a similar slide to the last one, just a little bit different of a perspective. So if you were to look at the left, we have a few categories, the first one being condition monitoring. So if you just want that condition monitoring, you would move to the right and see the blue kind of teardrops. Those are the pieces of equipment that you would need to get that.
Quick question about Optimize. Is there a subscription required for Optimize, or can you just buy the sensor individually and monitor the data on your own in some way?
Yeah, so there's no subscription necessarily required. So as I was saying in this first bucket, I was actually going to get right to that point. If you wanted just the condition monitoring portion where you're getting the vibration, temperature readings within the app, I'll show you some screenshots later where you'll get graphical trending. You can have the ability to do maintenance reminders or maintenance logs. All that you need is the optimized sensor. Download the mobile application. There's strictly just the hardware cost for the optimized sensor itself. But there's no fees or subscriptions associated with the optimized application. You're simply just then doing those maintenance rounds, coming within Bluetooth range to collect the data yourself and pushing out the data via your own cell service or Wi-Fi connection. There's no subscription. Where subscriptions are introduced would be the optimized gateway, as we need to cover the data charges to push out the data via its subscription there. So the only time you're running into a subscription is if you're introducing the optimized gateway. And there will be also a subscription for the Avener smart monitoring platform stations that you set up there. So next would be the asset lifecycle management. So if you wanted some things that would be introducing the Avener smart monitoring platform, some of the benefits there that I like to discuss is It's a little bit easier to share data with a vendor. So something I didn't mention with the optimized sensor, anyone who wants the data for the optimized sensor, if you're has to have physically paired with the sensor itself. They have to take their mobile phone, scan the QR code, pair it to it, and then after that, you could leave the state, whatever, get well without Bluetooth range. One person collects the data, it'll update your device for you. However, if you have never physically paired with it, if there was no chance for you to get your hands on it and pair with it, your app is not going to update it, and I can't necessarily share that. I would have to create a PDF file. You have the ability to create a report, and then I could text or email it, but you're not going to automatically get your mobile application updated unless you physically pair. So with a vendor, you have the ability to essentially give other users access to your sites or stations, so just a bit easier to give others access to the data if you wanted to. As I touched on, a vendor's its own standalone product, so you're not only getting the temperature vibration readings, but you can monitor our VFDs there. Really any third-party piece of equipment, which I think I touched on, that just has a Modbus table for you to input there. So now you can see all of your equipment in that single dashboard, which is nice. Or to take it a step further, if customers already have their own BMS or SCADA systems, we would have to introduce a vendor, and they can pull all the information from a vendor into their own BMS system or their own site dashboards. So if they're already familiar with their own systems, we can introduce a vendor, make the two systems communicate to each other, and write on their own dashboards. And then lastly, if it's truly a remote area where you don't want to take those maintenance rounds, that's where you would introduce the optimized gateway, and it's going to push the data out to everyone. So here, just an overview of the optimized sensor itself. So it is taking vibration readings in 3 different axes. We do have on the bottom center of the sensor an infrared non-contact temperature measurement reading. There's a little port underneath there you would see that's taking the temperature readings. The optimized sensor itself is rated NEMA 4, so it can be used in outdoor applications. The battery life, this is a bit unique to our solution here. A lot of the competitors' products on the market, once the battery fails, you do have to throw away the sensor, buy a completely new one. Not the case with ours. There's a few screws on the top of the sensor itself, then another couple screws on the battery. You take it out, replace it, you're back up and running. No data is lost. Really the only data that is lost is obviously the sensor's not taking readings while the battery is dead, so you just won't be capturing information during that time period. Battery life is 3 to 5 years, so a bit of a wide range. The reasoning there is upon programming the sensor, you have the ability to tell it how often to take readings. So you can take readings every 5 seconds, all the way up to, say, once every day or 24 hours, right? So depending on where you fall on that scale and how often it's taking readings is going to kind of dictate whether you fall in the 3 or the 5 year range of the expected life there. And then if you're installing these near some sort of power outlet, we do have an optional power supply. There's a little port on the side of the sensor that you can plug in, and you would never have to worry about battery health there. And then lastly, the standard mounting, you can kind of see the 2 feet sticking out. There's 4 round magnetic feet on the bottom of the sensor. That's how it's going to mount to the asset. However, if you don't have a magnetic surface, or you're just not comfortable using just magnets, although they are very secure, it's tough to get the units off of something. We do have a fixed mounting back bracket, so you can kind of directly attach it to the asset. Or if you have a smaller asset and it's a very tight radius or curved surface, let's say all 4 of those feet on the sensor just can't place on the unit because it's too tight of a curve, we have optional magnetic feet that are better suited for those curved surfaces. But the standard mounting can certainly be used on a curved surface. Here are some pictorial instructions. This would be sent with each unit. There are descriptions associated with each one. However, we have step 1 here is just telling you to download the optimized mobile application. Step 2 is telling you to register for it. Step 3, take the optimized sensor out, and with each optimized sensor, there's going to be shipped a screwdriver. On the back of the screwdriver, there's a magnet. That's how you wake up the sensor and how you put it in pair mode. So you hover the magnet over the LED, or there's a little Bluetooth icon there. You hover it over there for a few seconds. The LED should start to flash pink. That's letting you know that it's in pair mode or configuration mode. You'll go to your mobile device, and within the optimyze application, you will scan the QR code that's on the front of the optimyze sensor, or you have the ability to manually enter its serial number. So underneath the QR code, there will be a serial number listed. But once you do that, the LED on the optimyze sensor should flash blue. That's letting you know that you have successfully made a good connection to the unit. That Bluetooth connection was established. And then step 7 is just telling you to basically, what are you installing the sensor on? How often do you want to take readings? There are pre-built-in standards within the sensor, so you don't have to understand vibration or temperature levels. We have ANSI HI standards or ISO standards in there that are going to predefine certain thresholds for pumping applications based off of the horsepower size and pump type you select within the setup portion. However, if there's a different standard that you want to use, or let's say you just have a specific value in mind, you can set custom thresholds as well. But there are pre-built-in standards, so you don't necessarily have to be familiar with thresholds on what's good and bad. Next is the gateway. Once again, this is going to communicate via Bluetooth to the optimized sensors. You can pair up to 6 optimized sensors on a single gateway. So the only time you would need more than one optimized sensor, let's say you can't get all 6 sensors within 100 feet of the single gateway, or you have more than 6 sensors in a single room, then those would be 2 scenarios that you would need to introduce a second or additional gateway to the application. External communication, so we have a low power wide area network this is communicating out to, so there's LTE-M. Narrowband IoT is available, so there's 2 different types of communication that basically countries have, or they could have both. There's nothing a customer has to be aware of necessarily. It's just going to automatically pick the strongest connection and go with that. So users don't necessarily have to be familiar with that or pick anything. But the low power wide area network is a little bit different than a cell signal. It sends smaller packages of data, and it's a little bit more successful at penetrating walls and doing things of that nature. So we know a lot of these applications, right, pumps and things are going to be installed in mechanical rooms or basements that have limited cell service. So although you don't maybe necessarily have good cell service next to this, that doesn't mean the gateway's not going to work, because it is using a bit of a different external communication with that low power wide area network that is a little bit better suited for those environments. NEMO 1 rated for the gateway, so if this is outside, you'll have to put it in some sort of enclosure or protect it from the elements. No battery on this. It does require a 5-volt USB micro power supply to plug into it to get it powered up. And then 1-button pairing, I'll talk about now. So here's, once again, the pictorial instructions associated with the gateway itself. It's going to come with 2 different antennas. It's just telling you to screw in those antennas. The ports of the antennas are actually different sizes, so you can't mix it up, or you're going to get it right. And then number 2 is just telling you to plug it in with the power supply, hit the power button to turn it on. You should see all the LEDs light up to let you know it's getting power. Go to the optimized sensor that you want to pair to the gateway, put it in the configuration mode by hovering that magnet over the LED until it flashes pink. Once it's doing that, simply click the Bluetooth button. That's that 1-button press we were talking about. Clicking that Bluetooth button, and it should establish the connection. Once again, to know that you've done it properly or it was successful, the LEDs on both the gateway and the optimized sensor itself should flash blue to let you know that everything went well. And then you're just off and running. Lastly, the pressure sensor. This is once again communicating via Bluetooth, but to the optimized sensors. So the pressure sensors will have to be mounted or installed within 100 feet of the optimized sensors to get that data over. As I touched on earlier, you could measure just suction pressure, discharge pressure, both, or even the differential pressure across the pump if you wanted to. There's a replaceable battery. You could just unscrew the top of that battery. You'll find a battery in there that can be swapped out. And this will have a standard mounting method. It's a 1/4-inch NPT male thread. And then lastly, some more pictorial instructions that would be sent with each pressure sensor. So the first one there, that's the asterisk. That is just basically telling you you need an optimized sensor in order to use the Bluetooth pressure sensor. You can't just use that Bluetooth pressure sensor by itself. It needs to communicate through the optimized sensor to get the data. Step one, on the main dashboard of the optimized sensor itself, there's a little plus sign in the bottom right corner. That's how you would add any optimized sensors or Bluetooth pressure sensors to the mobile application. So once you click that, a pop-up should show up asking you, what are you adding, an optimized sensor or a pressure sensor? You're going to click pressure sensor. It's going to ask you to scan the QR code that's on the pressure sensor. Depending on what you pick, if you're just picking suction pressure or discharge pressure, it's going to jump to step 4. But if you select differential pressure, it's going to ask you then to scan the QR code of the second pressure sensor that you're going to be installing in the application. Once again, go back to the optimized sensor that you want these pressure sensors to talk to. You're going to put it in configuration mode till it flashes pink. You're going to scan the optimized sensor's own QR code, and then it should make that connection for you. Once again, the LED on the optimized sensor should flash blue to let you know that it's good. So here we just have a few screenshots of the optimized mobile application. The first two are your main dashboards. There's two different views. There's a map view, which is in the center. That's just simply showing you a little blue arrow with an optimized sensor in the middle of it where you have optimized sensors installed across the globe, essentially. And then there's list view, which then allows you just to take some pictures. You can name each sensor, so it just lists out every single one there for you. You can see little icons of sensors. It wouldn't be necessarily uncommon to have multiple sensors on a single pump. You may have one on a bearing housing, another on the motor. You're monitoring two different portions of that asset. If that's the case, you would see two sensor icons side by side next to that specific pump product there. But something I like to point out, everything on this is traffic light indicators. So what I mean by that is if you're seeing sensors that are green, that means everything is good. If you're seeing sensors that are yellow, which is some sort of alarm, or red, which is a more critical error, then that means that there's some sort of issue. So if you just log into the Optimize app, you're seeing everything's green, maybe that's as far as you go, right? You got your peace of mind, you're seeing everything is green, you're good. However, if you're seeing something red or yellow and you want to investigate it more, you should have some alarms. So you see a little bell icon in the top right corner. You would click that and it's going to tell you exactly what went wrong. So you'll see vibration and what axis, the specific vibration reading, date and time associated with that to take a look at. However, you can investigate a little bit more. If you click on the specific sensor on the main dashboard, it'll take you to this first screenshot here. And that is just basically going to give you a little bit more detail. It's going to give you the latest readings the optimized sensor took. So now you'll see the specific vibration levels that were last read, or the specific temperature of the asset. And once again, the numbers there, if everything's green, that's good. Yellow or red means some sort of issue is going on there. You might want to take a further look. And if you did want a bit more detail, once again, you can click View Trend. View Trend is going to take you to that middle screenshot, which is just a history of all the data readings ever taken, and they plot it on a graph for you. So on the top there, you can see two calendars. You can expand or narrow the time frame window that you want to investigate the data. But there you can see it. The screenshot actually doesn't have it, but if you look on the very bottom, it says learned range, data is not available. There you have the ability to take basically a 7-day analysis of a asset. The optimized sensor is going to create a blue bar essentially across the graph, and just to let you know the normal operating range of that asset. So it's not going to necessarily trigger any alarms if you go outside that normal range, but with some manual intervention or interpretation, you might start to see vibration or temperature levels drift out of that blue bar, just giving you even earlier warning indication that a potential problem may be happening or approaching. And then lastly, the last screenshot there, we have the ability to look at it in FFT chart. Basically, that's just doing a vibration count in the frequency domain. So if you're seeing kind of a heat map or excessive purple dots in, let's say, the first harmonics or 60 hertz, or second harmonics, which is 120 hertz. That could be an indicator of like a bent shaft or cavitation, so it just can kind of pinpoint, give you an idea of a specific issue that's happening. Circling back to the first screenshot, just a couple other things. You can see towards the top it says last updated on. It'll give you a date and time. So if you're not happy with the date and time, or if it was too far in the past, you can hit force read on the bottom of the screen. It's going to force that sensor to take a reading and update the information for you. Once again, Avener is the web-based platform which has the ability to pull in optimized data. So once again, here's just some similar screenshots. This would be the main dashboard once again, letting you know the number of stations or active alarms you have within that, right? So here's the alarm screen in a specific station. It's saying vibration and the x-axis date and time associated with that. But you can go to the analytics tab. So once again, it's just all the data in a graph. The bottom now there's a blue bar where you can expand or tighten the time frame of information you want to review. Another neat little feature is you can see the red bar going across the top, letting you know where that threshold actually is, and you can maybe find out you're approaching that. And then live data would just be the most recent data of temperature, vibration. And then lastly, I won't get into detail on this, but Avener OPC is that communication protocol, essentially that machine-to-machine communication that allows Avener to communicate to our customers' own BMS or SCADA systems. But at xylem.com/Avener would be the website for this product. We do have a user guide and white paper that kind of goes through that whole process on how you would establish that connection. But once again, that's just allowing users to pull in any information that we have in Avener into their own site dashboards there. So that's all I have on Optimize on a high level. Are there any other questions regarding Optimize, or if anything else came up regarding Hydrovar X? Now would be the time to ask any questions you may have. Okay. So again, oh yeah, I don't think we showed, but here we actually have an Optimize sensor mounted on a curved surface, just to give you an idea. So there's the 4 actually magnetic feet on the optimized sensor. Right here is that temperature port I was talking about on the sensor itself. If we look on the side, that's that optional power supply. You don't necessarily need to utilize this. There's a battery inside. But here would be where you would plug in that optional power supply if you didn't want to worry about battery life. On the front, this is that QR code I was mentioning that you would need to scan to pair to it. There is a serial number listed under it. The LED here with the Bluetooth icon. So right now we must have been shaking this pretty good at some point, but it's flashing red, so it's indicating there is some sort of issue going on there. As I mentioned, the 4 magnetic feet here, you can take these screws out and swap to the optional feet, or the fixed mounting bracket is how you would get those off. But this is a curved surface. It goes on there good. You know, all 4 feet are touching behind here. But to give you an idea, right, this is about the size of a credit card, just with some depth to it. So pretty small device, but this would be the optimized unit itself here for you guys to get a good look at. But yeah, last call for any questions you guys may have. If not, we'll go ahead and get this wrapped up. Really appreciate you guys taking the time to join us today on the call. Hopefully you found this beneficial, but at any point you guys think of something after the fact, do not hesitate to reach out to us and we can get those questions answered.
Seeing no further questions, I think we are going to wrap up for today. So thank you again for your attention and interaction during today's training. Please contact your Xylem sales rep for any additional questions, help specifying, or to price or order either the Hydrovar X or the Optimize. And until next time, take care.